see everyone. I feel like I'm in a classroom for real. My mom is a teacher, so I do have some experience. So nice to connect. I'm Gil. I'm the co-founder of Lava, CTO. We'll talk about Lava and the SDK. How is it working? What it's built on, and yeah, feel free to ask any questions at any time. So a bit about me. So I'm the co-founder and CTO of Lava. My background is I started in cybersecurity. So I'm originally from Israel. So I did 5 years at a top cyber unit. I founded a startup in cyber as well, where we built research technology into operating systems and kernels of phones, so iOS and Android. And after that, I got into the space by doing MEV. So if you're familiar, I was doing MEV on Ethereum. And that's what got me into the space to build a blockchain. A bit about Lava. We're 26 engineers, about 40 people. We started last year in April, and now we just released the Alpha SDK. And also we are running on testnet for a few months now, with over 1,500 validators that have joined and over 200 providers that have signed up to provide service on the network. So we'll talk about Lava, the protocol, and the different products that we have. And we can also do a quick demo after that. And also, if anyone wants to try the SDK, we can write some code and show you how to do it. So are you guys familiar with RPC? Yes? Okay. So I'll just go quickly. So RPC is a remote procedure call. It's like the way that we get data from the blockchain. So, when you run a node, you sync with the state of the blockchain. Come in, please. And then you get the data by using RPC. So basically, if you want to get the balance of an account, then you do an ETH get balance, right, with the account address on Ethereum. If you want to send a transaction, you have to use RPC, send it to the node, and it gossips about it to all the other nodes. The issue and the challenges that we have in Web3 right now is that so many chains have to host their own RPC, which is very difficult, and it's very hard to scale and run a lot of RPCs. So because once you have a lot of users from your dApp, they send a lot of messages, and it's very difficult to sustain. You have to scale those nodes, and it's expensive to do. A lot of validators also run nodes, but they do it altruistically. So there's an incentivization issue there. Sometimes they're incentivized by the ecosystem, but still it's difficult to find them. So you have to go and find many different RPCs, and sometimes they're not working, sometimes they're throttled or rate limited, so it's difficult. And then if you go to the Web2 providers, which are the bigger providers, then sometimes they're very expensive. They can be a single point of failure, right? So if they're down, there's no traffic, you can't get any information, you can't do any DeFi, you can't do anything from your dApp. And it's hard for them to add support to different chains. So if you go to the biggest Web2 providers, it's very difficult for them to go and add like different Cosmos chains, because there's a lot of Cosmos chains. So to go and add support 60 chains, it's almost impossible for them. That's why we built Lava, right? So Lava is a peer-to-peer protocol that we've built. It has an off-chain and an on-chain component. Basically, the on-chain component is a Cosmos chain. So it's built on Cosmos SDK, and it provides a settlement layer. So any provider can permissionlessly run a node, let's say for Cosmos Hub, and then connect to Lava Network by registering. And then any user can come and get service from these providers. So we're basically building an incentivization for node runners of any kind. So it's RPC, but we also are doing APIs. So indexing and different stuff like this, which I think is super important. One more point about this, the way we see how can we scale to many chains, right? How can we support 60, 100 chains is by basically having what we call contributors on the chain. So if you are coming from an ecosystem and you want to add support for your chain, then you can write the code to do it, put it as open source, and then you can get royalties for maintaining it and for creating these specs. So if you want to add support, you just write the code, propose it on chain, and then you can get paid to actually add new chains. So this is what makes it scalable to support many chains. So how does it work? From the top-down view, is that the dApp or the service, it downloads, let's say, the Lava SDK, or uses the server kit, which we'll talk about later, and it uses the protocol to basically connect with the best RPC node. So all these nodes that have permissionlessly joined the network, they're now being tested by the customer, by the end user who's using and talking to these nodes, and this is all done automatically by the protocol. So the end user continuously can check the different providers, see who responds the fastest, and then send him the transaction or get the data from him continuously, and also by geographic location. So we actually can dive deep into that. So how do we route for the best node? So we do it by using also latency, which is super important, right? So if your user is going to your dApp and they're based in Europe, then they can send a message to all the nodes and see who's the closest node that responds in the fastest latency. We also can talk about quality of service. So this is outside latency. So this is something like availability. How often do we get an error from this node? And we can all calculate this information to get the best service and the best pairing from the best nodes. The other thing we do is called data accuracy. So this is super important for me when I came into the space. I came from the cyber security industry. So I was shocked to see that we just get data from these RPCs, and there's no way to verify the data. We're like, okay, I guess it's from the blockchain. I guess it's real. Great. But with cyber background, you know that somebody might change the data, might do some phishing, which was actually done on some other providers through the RPC, might provide like fake information to make you make a bad order, like buy an NFT for, I don't know, an overpriced price, or like make a bad trade on Uniswap. So I think this is super important. But another element of this is freshness. So how do you know the data you're seeing is not stale? Like it's not the price of the swap pair from 2 weeks ago, or from like 5 hours ago. Maybe Pepe has gone up or it collapsed completely. You want to make sure you're making the right order on the swap. So these are the two things we call data accuracy. So first is like verifying the data is accurate. So we use an optimistic algorithm. So let's say every n queries we send to another node. We ask one node, we get a reply, and we send the same query to another node. And then we can detect if there's conflict. If there's conflict, we take the conflict, put it on chain, and let other providers vote on what's the actual correct solution. This is what we call optimistic. And the freshness guarantee is by, as I've said, when we talk to these providers, the client SDK, it sees what the latest block is for everybody in this pairing session. So you choose the ones that show you, frequently the latest block. One more thing that is important is also how incentivization comes into the picture. So when I think about RPCs, I think it's become a commodity, obviously, but it's also very hard to run many RPCs for many different chains. It's very hard to scale. That's why a lot of shops are very specialized on different chains, like EVM or Cosmos chains, or Move-based chains, or Solana, which has its own category because it requires a lot of computation. So one thing that we've built into this protocol is incentivization on the quality. Like when you talk to a provider and you get data from them, you check the latency, you check the availability and the accuracy, and then you score them as you go. For them to get payment from the chain, they have to send the score card on chain, and then their payment is based on that. So let's say more than 50% of the payment can be reduced from the payment to the provider if he provided really bad quality. So they have a built-in incentive to provide quality service. So one of the biggest initiatives working on right now is giving ecosystems the ability to incentivize RPC node runners and API builders to come and provide this public RPC, because we are seeing that they are struggling many times with working with many different centralized providers. So our focus is building these pools where you can go to, like a Uniswap pool, where you come to a page and you can see if you contribute a node for, let's say, Cosmos Hub, you can get a certain amount of payment based on how much incentivization was given by the ecosystem. So this helps boost the diversity and also helps bring the community back into running nodes and getting paid for running them. So you can actually go on our testnet and use our binary Lava D to get and see how many providers are on the chain. So I see we have some stats, about 280 providers. We provide over 20 chains right now, but it's ever growing because we have a wait list of providers as well that we slowly are onboarding. So we'll touch a bit about the 3 different products that we have. So we have the server kit. So the server kit is like an enterprise grade sort of gateway. These are all open source, by the way. So you can go, you can check out the code, you can compile it, you can run it yourself. The server kit is the implementation of Lava protocol in Golang. So it's much more performant. We also have the Lava SDK. So this is the same implementation, only in JavaScript. So it gives you the ability to do it from the back end, from the front end, which is pretty cool. And we're also now adding integrations for different libraries like Ether.js, Cosm.js, so that you can easily get the RPC data and without ever going to Lava SDK directly. You just import the Lava SDK and add it to your configuration, and you're set and good to go. And we have the gateway. The gateway is more like a plug and play. I think we have a bigger slide on that. So it's a UI front end that lets you create and get access to these chains, and just do it in a plug and play way. So you can plug and play our URL and put it in your dApp and get access, or you can connect with this to the SDK as well. So this is a schema of how the gateway works. Right, so we have the front end, the back end, and then we basically have a reverse proxy that sends the relays, the queries or the transactions to the server kit. So it's basically running the same software anyone can run to route the queries. So when a query hits the reverse proxy, it goes to the server kit, which runs the Lava protocol. The server kit sends the message to any of the providers based on their pairing and the quality, and gets the responses and sends them back to the user. The next one I want to talk about is the SDK in a bit more in depth and what it gives you to do. You can see here a snippet, and actually I think we're going to run this when I finish the slides and show you a bit. If you guys want to take a look and try it yourself, it's also super easy. But essentially, it's the same protocol implementation in JavaScript. So what's interesting about it is that from the browser, the user can actually get access to many different nodes without having like a set list or anything like that. So the protocol is built in a way that the user can get the best responses. As we've said before, all of that algorithms and all of those quality of service mechanisms are built into this code. So we just import it. You do like, let's say, Cosmos Hub.send relay, and you get access to many different nodes, which I think is pretty cool. So the latest innovation that we've had is to allow it from the front end. So I think something to think about is, let's say you're talking to a provider, right? How do you know, how can you prove to the provider that you're allowed to talk to him? Because you're talking to him from the browser, from the server kit. So this is something that we've worked very hard to do. So the traditional way would just be, okay, generate a key pair, sign your message, right? And then they know, okay, this he can talk to me because I can see on the blockchain that he has the money to pay me for the service, right? How do you do it from the front end? From the front end, you don't want to put your private key. I mean, it's gonna it's going to get stolen, and everybody will use your private key, and who knows what they can do with it. So the idea is to use something we call badges. So think about like a WeWork badge, right? Or the bracelet for the event. You go to the reception, which can be the Uniswap DApp. You get the badge. This is all done, by the way, seamlessly, obviously. The user doesn't know anything about this. But for us devs, it's more interesting. You get the badge, and then you add it. You generate your own key pair. You send the public key to the badge server. The badge server signs it, sends it back to the user, and now the user can use the badge with his private key. So the server never knows the private key, only the user knows the private key, and then he can use that badge, include it in the relay to perform the connection. So in this diagram, you can see the setup, how we set it up. So initially you get the pairing list. So you use the same protocol, like the Lava protocol, to talk to Lava providers that have Lava nodes. You get the list of providers that are available, and then you do the same thing, let's say to talk to StarkNet or Cosmos Hub or anything like that. And then you can just send RPC calls to whoever is on the list, provider 1 or provider N or whatever, and you can get the data, or do it for any other chain. And I'll show you in the demo how we can just switch one letter, let's say Cosmos 3 to Cosmos 5, and move between Cosmos Hub and Osmosis. So it's super simple and easy. And the vision is obviously to be able to access all the chains, right? And all the APIs from one place with one subscription, with one SDK, with any integration. So the server kit, currently it still lives inside the Lava D binary, but actually separating the two into two repositories, into two binaries, same repository, but you'll be able to run it, and basically you can listen on different ports and ask for different chains, and then you can just talk to them like the regular Web2 providers. So this is what the server kit does. And a little diagram for that. So basically any front end or back end can talk to the port that the server kit is listening on, take the relays and send them to the providers in the same way that we showed before. So a bit about the features. I think we discussed a lot about all the multi-chain support. We can have many different chains, all the chains basically from the SDK with just a couple lines of code, which is interesting. As concurrency, so it can do, you can talk to many different providers at the same time, right? So you're not just stuck with one URL. You have like these 10 providers, and you can, query the shit, really query them hard and get all the data from them, and be very fast for users. We're working on integrations. So this is Ether.js, Cosm.js, and many others. And then the idea is that we're going to have subscriptions on chain. It's actually already implemented. So if you go to our testnet, you can buy a subscription from the chain. And this gives you access to all of this. And you just need to renew it every month or every year, and not think about overuse or not think about, pay as you go situation, which is a bit difficult. So to get the easiest way to do this is just to go to the gateway. If you want to use it in the backend, then you can use the private key, and the gateway can help you set it up. And you can also use the badges, set it up from the gateway. I'll do a short demo. Any questions?
I have a question about data accuracy. On some requests, the data response are specific to the node. How do you?
Oh my God, it's a great question. Okay, so that's something that we've struggled with a lot, right? So we have like 20 plus chain support, and each chain has their own RPCs. And each chain has their own different peculiarity, like different situations that are different. And some of the RPC replies have content that is not predictable or is not reliable in terms of determinism, right? So what we built is basically we parse, semi-parse the replies, and we are able to take out the fields or only take in the fields that we think you should have data accuracy for. Okay. Also, we can just disable completely for some APIs the data accuracy. So, for example, if you're asking for the mempool or my list of peers, something that is very local, we just disable data accuracy for that because there's no way to do it. Any other questions? Okay, so I want to show you a little bit about the gateway. So basically, it's a super simple page. Anyone can join right now. It's actually free, so feel free to sign up. You can create a project, select the different chains that you want. If you want Cosmos, Evmos, Juno, you can add a project name and create. I already created one. And then, let's say I want to talk to Cosmos Hub. I can open Cosmos Hub. I can have Cosmos Hub testnet or Cosmos Hub mainnet. And I can use it as a plug and play endpoint. This is the front end that I was talking about. So for example, I can run and get the latest block on Cosmos. I don't know if you can see the UI, but you have the latest height here. Or I can use the SDK, right? So to use the SDK, I just click here and I have two options. I can use it in the front end using badges, as we discussed. So it's like getting a badge from WeWork. We have a badge server, which you can connect to and get the badge and basically perform the relay. And the other option, if you want to use it with a private key in the backend, you can also add your public key to this will actually send a transaction on the Lava testnet and add your public key to the account, to the project. So let's see it in action. So I have, I already ran like npm I Lava SDK, initiated the folder, and now I have very simple code that basically uses the Lava SDK, configures it. So, by the way, the badge server is also open source, so anyone can run their own badge server for their own dApp if they wanted to. The project ID, so that we can debug, we can know like where are these queries coming from, and we can see it in our analytics later on. The chain ID, so Cosmos. Here I think it's Cos3. I think it's Osmosis. RPC interface. So we support gRPC, we support REST, and we support Tendermint. For any of you out there who are using gRPC, we also support gRPC. We put a lot of work to support. It's not an easy feat, if you know what I mean. And you can set a geolocation. So you can do global. I think 2 is global. Or you can choose a more specific one if you wanted to. Next thing we're going to do is going to send the relay to the whatever provider we get and get the ABCI info. So let me just execute that. And you can see we got the response from it's Osmosis, and we have the latest block height, which is 973, and if we run it again, we should see 975. So we see it's advancing, and it's probably bringing it from a different provider each time, which is cool. And if we just go here, change the number from 3 to 5, then we see it's Gaia. So it's Cosmos Hub, and we have the latest block from Cosmos Hub. This is how simple it is, just to get the.
Is it possible to see like from which node we actually query?
You would have to look into the network. I don't have unfortunately, we don't have a verbose mode, but we definitely need to add that.
Even like for compliance, probably.
For compliance, so we're planning to have a subscription for enterprise where you can choose to whitelist the number of providers that you want, so that you only work with the bespoke providers that are KYC'd, for example.
But is it normal that the first response data is Osmosis app and not Gaia app?
Sorry?
For the first answer, you asked to Cosmos Hub free?
No.
You get the response from Osmosis?
No, first one I did Cos3, which is our name for Osmosis, sorry, our name for yeah, that's how we call it in Lava.
Okay,
That's
cause
it.
3 is osmosis.
Yeah, so cause 3 we have osmosis,
Okay. Okay.
and the second one is for Gaia, which is cause 5.
Okay.
That's good feedback. We should change the name.
Wait, the name is confusing, you're saying?
Yeah. A lot.
Well, you know, we try our best with the naming. It's difficult to have 20 chains.
You
You
know,
obviously
John
have
5,
those chain IDs
John 1.
somewhere.
We can easily change it. It's in the specification of. I appreciate the feedback. Thank you. Yeah. So this sums up the demo. Any other question, guys? Yes.
Is there any way to handle real-time data, like once it's happening, or we just need to query everything?
Oh, you're saying do we support subscriptions like Tendermint? Yeah, we do. I believe the SDK currently. So the SDK is currently in alpha. We just released it like last week. So there's still a lot of work to be done. It's not so. Anybody wants to join in and help us, push it forward, we'd appreciate it. But we have support for the subscription on the server kit. But very soon we'll add them to the SDK as well. So you'll be able to listen to new blogs and different events. Any other questions? If not, and if you have any other question later, come say hi and ask me any question you want. Feel free to join our Discord. We'd love to see you there. We also have a very involved community, and if you write a message, you might get like a very long answer from one of the developers. Okay, a very angry. No, I'm joking. So feel free to join us. We'd love to see you there. All right, thank you guys. Thank you.